Convert the point 3, 3 pi divided by 2, 5 pi divided by 6, which is given in spherical coordinates, to Cartesian coordinates or rectangular coordinates. So our goal here is to find the coordinates x, y, z, given that we know rho equals 3, theta equals 3 pi divided by 2, and phi equals 5 pi divided by 6. So to find the Cartesian coordinates, we'll be using the formula that's provided here. So we know x is going to be equal to rho times sine phi times cosine theta, which would be 3 times sine 5 pi divided by 6 times cosine 3 pi divided by 2. And y is going to be equal to rho times sine phi times sine theta. So we'd have 3 times sine 5 pi divided by 6 times sine 3 pi divided by 2. And then finally z is equal to rho times cosine phi, which would be 3 times cosine 5 pi divided by 6. Now to find these trig function values, we can use a unit circle or use reference triangles. Let's go ahead and sketch these two angles in standard position and sketch the reference triangles. So 5 pi divided by 6, which is also equal to 150 degrees, would have the initial side here, and the terminal side would be approximately here, giving a reference angle of pi divided by 6 radians, or 30 degrees. So this would be the reference triangle, with again a reference angle of 30 degrees, or pi divided by 6 radians. So we can label the three sides 1, 2, square root 3, where the short leg is 1, the hypotenuse is 2, and the long leg is square root 3. But because we're in the second quadrant, where x is negative, this would be negative square root 3. Again, this is the reference triangle for 5 pi divided by 6 radians. And then for 3 pi divided by 2, we actually cannot sketch a reference triangle. The initial side would be here, the terminal side would be here along the negative y-axis. But if we select a point on the terminal side, let's say this point here, and assume it's on the unit circle, it would have coordinates 0, negative 1, where we know x equals cosine theta and y equals sine theta. So we can use this point here to determine the trig function values for the angle 3 pi divided by 2. And we'll also verify these on the unit circle once we finish. So for x, we have x equals 3 times sine 5 pi divided by 6 would be equal to the ratio of the opposite side of the hypotenuse, which would be 1/2, times cosine 3 pi divided by 2 would be equal to the x-coordinate of this point on the unit circle, which is 0. So x is equal to 0. For y, we have 3 times sine 5 pi divided by 6, which we know was 1/2, times sine 3 pi divided by 2, which would be equal to the y-coordinate on the unit circle, which is negative 1. So y is equal to negative 3/2. And then for z, we have 3 times cosine 5 pi divided by 6, which would be 3 times the ratio of the adjacent side of the hypotenuse, which would be negative square root 3 divided by 2. So we have z equals negative 3 square root 3 divided by 2. So the Cartesian coordinates are 0, negative 3/2, negative 3 square root 3 divided by 2. And again, let's go ahead and just verify our trig function values on the unit circle. Well, here's 5 pi divided by 6, and here's 3 pi divided by 2, where the x-coordinates give us the cosine function values, and the y-coordinates give us the sine function values, which does verify we found our trig function values correctly. I hope you found this helpful.